So what we're going to do with the remainder of these examples is we're going to graph them using calculus and what we've been learning with curve sketching. We're also going to briefly look back at how I graphed this in the past to sort of remind you of some of the math you've learned in the past. So for this one, with calculus, okay, if we wanted it, we know that it's a parabola. If we wanted to find its vertex, take the derivative, set it equal to 0 to find out when the slope is horizontal. And when we do that, we get x is equal to 1. So we know our vertex is going to be on our graph when x is equal to 1. If you plug 1 back into the original equation, you're going to get 7 minus 14, negative 7, plus 3, negative 4. So there you already know 1, negative 4. Now, because you know things about parabolas, you probably wouldn't even have to do the remainder of the things you do with calculus to find out stuff about the equation. But what we did is once we find out our critical point, which is at 1, because that's a place where it could change from increasing to decreasing, you plug in values into your derivative, into here, to find out where's my derivative positive, where's my derivative negative. So if I choose a value less than 1, say 0, and I plug 0 into here, 14 times 0 minus 14, I'm going to get a negative number. And anytime your derivative is negative, that means your slopes are negative. That means your equation is going down. Now we already knew this because it's a parabola. And so our graph from left to right should be going down. If you plugged in a number larger than 1, say 5, say 10, say 6 billion, times it by 14 and then minus 14, you will get a positive value, which means your function changes to increasing, which we can see after our vertex, sure enough, from left to right, it starts going up. From last year, if you were graphing this one using old techniques, you would have, I'll do it in a different color, you would have factored out the 7 and completed the square. Divide this middle number by 2 and square it, which would mean you'd add 1, but since I've added 7, I need to subtract 7. And you'd get the vertex as 1 comma negative 4 that way. Perhaps you also remember from last year that this 7 in front, which is the a value, which you can see from the original equation, means your parabola is opening up. It also tells you if you wanted to find another point, you could go over 1 up 7. And 2 comma 3 would be another point on our graph. So for parabolas, maybe you're really good at parabolas. I'm not sure if the calculus is faster or not. Maybe completing the square is just as fast. Sometimes this was a nice one because the completing the square had no fractions, no nasty values, whereas the calculus helps you get away from that a little bit as well.